Kubernetes pod live migration. That's what Cast AI calls it when they dynamically move your pod to a different node without downtime or data loss. They've built a Kubernetes controller that works with CSI storage and CNI network plugins to copy your running pod data, the memory, the IP address, and the TCP connections from one node to another in real time. Welcome to DevOps and Docker Talk, and I'm your solo host today, Bret Fisher. This YouTube live stream was a fun one because I got to nerd out with engineers Philip Andrews and Dan Muret from Cast AI on Kubernetes pod live migrations and how it works under the hood. We talk about use cases for this feature, including hardware or OS maintenance on a node, maybe for right sizing or bin packing your pods for cost savings, or moving off of a spot instance that's about to shut down. Or really anytime you need to move a daemon set that would cause an outage if the pod had to restart or be redeployed. I don't know of any other turnkey way to do this on Kubernetes today, but I've got a feeling that Cast AI has got a winning feature on their hands, and I'm glad that we got to dig into it. Over 20 years ago, the virtual machine vendors built this live migration feature into their products, and finally in 2025, we're now able to do that in Kubernetes. Let's get into the episode. Welcome to the show.
Right.
All right. Both of these gentlemen are from Cast AI. Philip is the global field CTO at Cast AI. What exactly does global CTO do?
Handling a lot of our large customers, a lot of the strategic partnerships, usually new technologies. So working with a lot of our customers on showing them new technologies, helping them prove concepts with new technologies. It's been kind of a cool role. Basically on the technical customer facing side, I get to do a lot with our largest customers and solving some of the hardest problems.
Nice. When you don't know what the title is, it makes it sound like you just live in an airplane. It sounds impressive. And on the right over there, we've got Dan Muret, or Muret. I really don't know my French, so that's probably a horrible pronunciation. Dan is here. He's the senior sales engineer with Cast AI, or one of them. I want to make you the senior sales engineer so that you sound very elite. Welcome, Dan. Who could tell me about what's the elevator pitch for Cast AI? Because I've known about you all for years. I've visited your booth at KubeCon at least a half a dozen times over the years. What's the main benefit of Cast AI?
Sure, I can grab that one. When Cast AI was founded, it was to solve a problem that our founders had in their last startup years ago, which was every month their AWS bill was going up 10%, regardless of what they did the month before to try to mitigate and manage costs across the infrastructure. They sold that startup to Oracle. When they finished that Oracle time, they went and figured out how to solve this problem. They said, well, Kubernetes is going to be the future platform. We're going to make our bet on Kubernetes. And the only way to solve this problem is through automation, because doing things manually every month, one, it's tedious, it takes up a lot of time, and two, it's just not helpful, right? You save a little bit it's 2 steps back for every step forward you make. With Cast AI, it's fully automation first, right? We made the effort that everything was going to be automated from the start. When it comes to node auto-scaling, node selection, node right-sizing, workload right-sizing, everything to do with Kubernetes, everything we implement is automated. And that's where the live migration piece came in, being able to automatically move applications around within the cluster without having downtime. And that's where application performance automation comes in. Moving from this application performance monitoring mindset, Datadog has made a lot of money on that. I don't know if I'm allowed to say that, but they've done very well and they have a fantastic platform. We love Datadog. But you get data overload. You end up with metric overload, and actioning on those is very hard. Where we need to go from here, especially with the AI mindset that we're moving into, is automation of that application performance. And that's what Cast AI is leading the way in.
Nice. When you all reached out and I learned about the fact that you now have live migration, it took me back to almost 25 years ago when that was first invented for VMs. At the time, it felt like magic. It did not seem real. We all had to try it to believe it because it seemed impossible to move from one host to another, maintain the IP, maintain the TCP connections. Surely I'm going to freeze up and it's going to be like a frozen screen. We all just assumed that eventually, and maybe at first it was a little hiccupy. I think if I remember correctly, like 2003, 2005, it was one of those where it wasn't quite live and it was like very short amounts of gaps. And eventually it got good enough that it was live. I was running data centers for local governments at the time, so I was very interested in this because we were running both ESX and Hyper-V. So I was heavily invested in that feature and functionality. So when I saw that you were doing it to Kubernetes, my first thought was, why did this take so long? Why don't we have this yet on everything? Because it's clearly possible. It's technically possible. Obviously, it's not super easy. It requires a lot of low-level tooling that has to understand networking and memory and disk writes and all that kind of stuff. So I'm excited for us to get into exactly how this sort of operates for a Kubernetes admin. And I really feel like this show is going to be great for anyone learning Kubernetes or Kubernetes admins, because to talk about the stateful set and the daemon set problem of we've got stateful work. Everyone I know almost has stateful workflows in Kubernetes. I would say, I don't know about you all's experience, but to me, it's an exception when everything is stateless in Kubernetes nowadays. Do you find that to be the case?
We talk to customers all the time, right? And yeah, used to, just a couple of years ago, right? It was a lot more stateless, web servers, whatever. Now we're definitely seeing a shift to more stateful workloads, whether it's legacy applications being forced into Kubernetes as part of a modernization project or whatever. We're seeing a lot more stateful workloads in Kubernetes for sure.
Particularly amongst the Fortune 100s, Fortune 500s, right? Because you've got this modernization, and I put it in quotes, where modernization means taking some crusty old 15-year-old application, containerizing it and shoving it in Kubernetes and calling it cloud native, the flawed approach of lift and shift. And you end up with a lot of applications that are in Kubernetes. They're listed as a deployment, but you can't restart them without your customer having a significant outage.
Right.
It goes against everything Kubernetes was built on, but that's the world we live in today. When we first launched live migration, and I posted about it on LinkedIn, some of the first questions I got was, why is this even needed? If you're doing Kubernetes correctly, live migration shouldn't even be a real thing. Yes, right. But 95% of the customers I deal with don't do Kubernetes the right way.
Well, yeah, I honestly think we could argue that's a great point. When Docker and Kubernetes were both created, it was like stateless because it's easy, move everything around. It's wonderful. But I think that this channel, if there's anything consistent about this channel over the almost decade that it's existed, it's that it's all containers. Like, I don't care what the tool is, we're doing it in containers. The large success of containers is because we could put everything in it. So many evolutions or attempted evolutions in tech have been, well, you're going to have to rewrite to, functionless, functions, you're serverless. You're going to have to write functions now, or you're going to have to rewrite this language or whatever. And I think that's like the secret sauce of containers, was that we could literally shove everything in it. It's also the negative. And so there's a thing that, I don't know if I learned it from a therapist or whatever, but often our weaknesses are just overdone strengths. And I feel like the strength of containers is that you can do everything with it. You can put every known app on the planet in it. They will eventually work if you figure it out. The overdone weakness is that we're putting everything in there, which makes managing these infrastructures very hard. Yeah, you have to assume everything's fragile until you are sure that it's truly stateless. Even stateless, people say stateless, and what they really mean is it doesn't care about disk, but it definitely cares about connections, which is, when we're trying to talk about stateless, that's not technically accurate. Like, when we say stateless, we should probably mean also doesn't care about connections, at least once the connections are drained. It's an interesting dilemma we all have in infrastructure of, we have the power to be able to move everything and do everything, but also everything's super fragile that we're running at the same time. So how do we even manage that?
We've encountered a lot of teams that swore up and down they were stateless right up until you started bin packing their cluster. It's like, wait, why are we having all these restarted pods? We're like, because we're bin packing and we're moving things and we're getting better optimization. They're like, but my container restarted. Well, yes, that's what containers do in Kubernetes.
Right. And for those that are maybe just getting into Kubernetes or haven't dealt with large enterprise forever workloads where they just can't be touched. I've had 30 years in tech of don't touch that server, don't touch that workload. It's fragile, it's precious, but it's also probably on the oldest hardware and the least maintained. So the idea of one of the performance measures that any significant sized Kubernetes team is dealing with is the cost of infrastructure. And then we keep getting told, I think this was just in the last year at KubeCon, that even on top of Kubernetes, we're still only averaging like 10% CPU on average utilization across nodes. Like we still are struggling with the same infrastructure problems that we were dealing with the last 30 years, even before VMs, before virtualization. That was the same problem we had then, because everybody would want their own server and they always had to plan for the worst, busiest day of the year. So they would buy huge servers, put them in, and they'd sit idle almost all the time because they barely got 5% utilization. So I can see where, like, one of the core premises of something like an application performance tool is that we're going to save tons of money by bin packing. Can you explain the bin packing process? What does that look like?
So one of the big things with Kubernetes is the scheduler will typically round robin assign pods to nodes. If you have 10 nodes in a cluster, your pods will more or less get evenly distributed to those nodes in the cluster. You can manage that with certain different scheduler hints and certain scheduler suggestions to steer that towards, most utilized, least utilized, et cetera. But at the end of the day, you're going to have spread out workloads across your nodes. Bin packing is basically the defragmentation of Kubernetes. Right. Back, Bret, when you were first starting out, when I was first starting out, and you could actually defragment a hard drive and you got to move the little Tetris blocks around the screen.
Good days.
Being able to do that in a Kubernetes cluster can mean massive, massive savings on the actual utilization of that cluster, because now you free up a bunch of workload, a bunch of nodes in the cluster that are no longer necessary. You can delete those off. And when you need them, you just add them back. That's the joy of being in a cloud environment. You can use the least amount of resources when you don't need them. So for instance, add, your off busy hours, your nighttime hours. And then when you start needing them again, you spin them up, you add more to it, you scale up during the day. And being able to do that process over and over again every day is how you can optimize your cloud resources. What we see is that people have so many stateful workloads, whether it's stateful in real statefulness or stateful in this is a really poorly architected application, or stateful in this application takes 15 minutes to start up and it's a monolithic and I can only run one copy of it, so I can't move it. All of those things causes so you can't bin pack a cluster, right? You can't move those things around. So what ends up happening is people just end up with these stateful workloads scattered throughout all 10 nodes. And even if the 10 nodes are only 60% utilized, you can't get rid of any of them because it'll cause some kind of service interruption. And that's where live migration allows you to move those stateful sensitive workloads. So now those 10 nodes can go down to 6 or 7 nodes without having a service interruption, even if there's less than ideal workloads scattered throughout the cluster.
Stateful versus stateless versus where's the scenario for where we need a live pod migration? And to those that are perfect in all their software and they control all the software that runs on Kubernetes. I don't know who those people are, but let's just say they exist. Then this isn't needed. Every database has a replica or database mirror, so you can always take a node down. Every pod properly has proper shutdown for ensuring that connections are properly moved to a new pod. By the way, I used to do a whole conference talk on TCP packets and resetting the connection to make sure it moves properly through the load balancer to the next one, and having a long shutdown time so that you can drain connections. That world of shutting down a pod is so more complicated than anyone gives it. Everyone treats it like it's casual and easy, and it's just not. If you're dealing with hundreds of thousands or millions of connections, there is a lot of nuance and detail to this. And I often end up with teams where they implement Kubernetes. It's that sort of predictable pattern, right? They implement Kubernetes, move workloads to it. They think Kubernetes gives their workloads magic, and then they just start trying moving things around, and they realize when their customers complain that the rules of TCP, IPs, load balancers, and connection state, all these rules still apply. You have to understand those lower levels. And obviously disk and writing to disk and logs for databases and all that stuff, that's still there too. I think the networking is where I see a lot of junior engineers hand-waving over it, because quite honestly, the cloud has made a lot of the networking problems go away. So we don't have to have Cisco certifications just to run servers anymore. We used to, but now we can get away with it till a certain point in the career or complexity level. And then suddenly you're having to really understand the difference between TCP and UDP and how session state, long polling, or WebSockets, how all these things affect whether you're going to break customers when you decide to restart that pod or redeploy a new pod. I love that stuff because it's super technical and you can get really into the weeds of it. And it's not, I wouldn't call a solved problem for everyone. And my understanding of something like a live migration is it takes most of those concerns. It doesn't make them irrelevant, but it does deal with those concerns. Am I right? In terms of networking, we're talking about live migrations having to be concerned with IPs and connection state, stuff like that.
Yeah. So with being able to do the networking move of things, to your point, reestablishing those sessions, one of the big things we see is long-running jobs. If you've got a job that's running for 8 hours and it gets interrupted at 6, you've lost that job. Yeah. Even if you try to move it from one to, there's some checkpointing involved. A lot of times, like on a Spark workload, the driver will just kill the pod and restart it if it senses any kind of interruption in the networking. So the networking is super important there, being able to maintain that. Mm-hmm. Long-running sessions, WebSockets, to your point, we've actually tested this extensively with WebSockets. WebSockets stay connected. And we're still in those early vMotion days. There is a slight pause when we move things.
Yeah.
It took vMotion multiple years before they got it kind of really ironed out. We're moving probably faster than them because we have a lot of experience, of the experiences they went through and the research that's happened since then. So I think we're moving pretty fast on shortening that time window. But what we found is you queue up all the traffic, and once the pod is live on the new node, the traffic is replayed and all the messages come through. So even on something like a WebSocket, you don't actually lose messages. They're just held up for a few seconds. And that's extremely important for maintaining that connection state like you were mentioning. One of our customers that we're working with this heavily on, they run Spark streaming jobs. So they're 24/7, 365, pulling off a queue, running data transformations and detections, and then pushing somewhere else for alerting mechanisms. If they have a pod go down, it takes about 2 minutes to get that process restarted, pull in all the data that they need again. That's 2 minutes of backlog. They have super tight SLAs. They have a 5-minute SLA from message creation to end run through the entire detection pipeline. So if you've got a 2-minute delay on that shard in your Kafka topic, that's a huge chunk of that 5 minutes that you just ate up. You're talking all the other pipeline. It's very easy to start missing SLAs there. You can't take maintenance windows. If you're 24/7, 365 and you're doing security processing, you can't be like, well, security is going to be offline for 10 minutes while we move our pods around. It's just, that's not acceptable in that world mindset. So keeping that connectivity, keeping the connection state, being able to keep everything intact, keeping the Kafka connection, keeping the Spark driver connection is all super important with being able to move that entire TCP IP stack over from one node to another during that migration process.
Yeah. And I mean, we're really talking about a lot of the different kinds of problems that come with shifting workloads, like being able to say, walking into an environment and sort of being your own wrecking ball and your own chaos monkey and saying, I'm going to go over here and push the power button on this node, or I'm going to properly shut down this node. Do you have everything set up correctly so that connections are properly drained? That is such a, I would say, a moving target, especially because every time we've had these processes where I've had clients where we go through this exercise of, we're going to do maintenance on a node and we're even going to plan for it. And then we do it. And then we fix all the issues of the pods and the shutdown timing and the Argo CD deployment settings that we need to massage and perfect. And then, 6 months later, if we do it again, the same thing happens because now there's new workloads that weren't perfected and weren't well tested. If I can make a career out of actually being like a pod migration guru, like that sounds like my kind of dream job, where we crash and break everything and then we track all of the potential issues of that. And we are like a tiger team that goes pod by pod and certifies it as like, yep, this pod can now move safely without risk because we've got everything dialed in. We've got all the right settings. I feel like that's a workshop opportunity. Maybe sell something on that because there's so many levels of complexity. We haven't even talked about like database logs and database mirroring. You can't really spin up a new node of a database and let it sit there idle as a pod while you're waiting for the old one to shut down. They can't access the same files, blah, blah, blah. It just depends on the workload, on how complex this all gets. But I'm assuming also that when we talk about something like live migrations, we're not just concerned with networking, we're also somehow shifting to storage. I'm guessing there's certain limitations to that where you're not replicating on the back end volumes. I guess you're just using like iSCSI reconnects, or how does that work? We haven't really got into the solution, but I know you're only on certain clouds right now, and I'm assuming that's partly due to the technicals of the limitations of their infrastructure.
Right, exactly. Each cloud has different kind of quirks around how they function, what the different technologies look like around them. Somebody had asked about being able to move, larger systems, are the limits around it. And it depends on the use case, right? If you're talking spot instances, being able to move from one spot instance to another spot instance in a 2-minute interruption window on AWS depends on how much data. If you're trying to move 120 gigs of data, physics is working against you. You don't have enough time in that 2-minute window to get enough through the pipe over to the new system. Right. Now, if you're talking small pods, if you're talking less than 32 gig nodes, you can move that fast enough. 64 gigs, maybe on the edge, depends on how much other network traffic is tying up the bandwidth. 64 gigs is getting on the edge that you can move in a 2-minute window. That other example that I was talking about, those long-running Spark streaming jobs, even if they're running on demand, line migration is still a massive benefit because now you can do server upgrades without taking an outage. You can create a new node running your new patch version of Kubernetes, running your new patched OS, and migrate the pod from one to the other. your time to replicate is less important. Even if it takes you 3 minutes, 4 minutes, or 5 minutes to replicate the memory from one box to the other, who cares? It's not going to be paused for that long because what we're doing is we're doing delta replication. So you replicate a big chunk and then a smaller chunk and then a smaller chunk until the chunk is small enough where you can do it in a pause window. And so now when you're moving a huge service from one to the other, same thing if you're talking like NVMe local storage. We've got another customer we're working with, and it's a different set of problems. They have a terabyte of NVMe that they use on local ephemeral disk on every node that needs to be replicated from node to node when they do node upgrades. That takes about 20 minutes to replicate all of that from one node to another, even on high throughput disks, on high throughput nodes. But if it's happening in the background while everything else is humming along nicely, who cares? Keep replicating it over, you keep going down to deltas, and then once your deltas get small enough, you pause for 6 to 10 seconds, depending on how big the service is, and then you slide it over. A lot of these things are being solved. We're actively reducing these pause times by being able to do more prep behind the scenes, being able to do more processing behind the scenes. Everything is operating as a container plugin. I saw somebody asked about on-prem. We will be supporting on-prem. We will be supporting other solutions. The big catch there is everybody has some different flavor of networking and different flavors of things behind the scenes. The actual live migration piece right now could apply to any Kubernetes anywhere. It's the IP stack that gets a little trickier because you've got Cilium running places, you've got Calico running places, you've got VPN, VPCCNI running places. Everybody has different networking flavors. So being able to maintain network connections when you do the migration is largely the more difficult part of the whole process. Being able to move the pod isn't that bad. So if you've got workloads that you can reestablish connections and the connection resetting is not a big deal, but you don't want to have to restart the pod, that's fairly straightforward. We could pretty much do that today across any container compatible Kubernetes. It's specifically the networking that causes a lot more hardships because everybody has a different flavor of networking. For AWS, we were able to fork the open source AWS node CNI and create our own flavor of it that now handles the networking piece. So we're using the open source AWS CNI code and we've modified it and now it works just fine for our purposes. We're doing something similar on GCP, working with the GCP. GCP, if I recall, is using Cilium under the hood for their networking.
Yeah.
So we're going to be building a similar plugin for their Cilium side.
Yeah. And the nice thing is, I guess, if you build it for Cilium, would it work universally across any Cilium deployment in theory? I mean, I'm just thinking of the most popular CNIs. And if you check those off the list, it suddenly gives you, a lot more reach than having to go cloud by cloud or OS by OS,
Exactly. Our first iteration of this back in January, February, the first version that we demoed was actually Calico. But a lot of people were like, I don't want to have to rip out my cluster and rebuild it with Calico as the CNI. We were able to figure out a way to work with the VPC CNI as a backing basis there. So Calico's pretty much already built. We've got AWS CNI now built. Cilium's our next target. I saw somebody asked about Azure. Azure is probably going to be early 2026. We'll be EKS, GKE, and then we'll work on AKS, and then we'll work on-prem solutions after that. So on-prem will probably be sometime in 2026.
Yeah, I can remember going back to the 2000s. I can remember when we went from delayed migrations or paused migrations to live migrations. I can remember reading the technical papers coming out of VMware and Microsoft, and they were talking about the idea of these deltas continually repeating the delta process until you get down to zero. Or like you can fit it in a packet and then that's the final packet kind of thing. I don't know why I remember that all these years later, but I do remember that I thought that was some pretty cool science, like some pretty cool physics across the wire. Because back then we were lucky if our servers had 1 gigabit, didn't have 200 gig workloads or anything like that. This actually led me during my research, and we could talk about the idea that there are attempts in Linux over the years to try to solve this universally. I did some research before the show and saw some projects around ML workloads in particular. A lot of engineers, whether it's platform engineering or just the ML engineers themselves, interested in this because of the sort of the problems of large ML or AI workloads today where you can't interrupt them. If you interrupt them, you have to basically start over. It's sort of a precious workload while it's running, and it might be running a long time. Do you have AI and ML workload customers where are they maybe part of the first movers to move onto something like this? I'm basing it on the KubeCon talks and things that I've seen out there.
Large scale data analytics is definitely one of the big players here. A lot of it's Spark driven data analytics that we're seeing because of exactly that problem. A lot of these jobs will be running for 8, 10, 12, 14, 16 hours, and running those on demand at the scale that they're running them at is extraordinarily expensive. So the big ask is, how do we get those workloads onto spot instances where when we get the interruption notice, we can fall back to some type of reserved capacity and then fail back to spot. So basically, the goal is to move to this new concept where in your Kubernetes cluster, you have some swap space, whether that's excess spot capacity, 2 or 3 extra nodes of spot capacity, or a couple of nodes of on-demand capacity, where if you get a node interruption, you can quickly swap into those nodes. And then once you stand your new spot instance back up, then you can swap back to that spot instance. That's where we're headed. That's what Q4 is going to be working on this year, is to be able to automate that entire process to where you can float back and forth between reserve capacity and spot capacity to really save on those data analytics jobs, those large ML jobs. We're not to the GPU side of things yet. I'd love to get us to where we can migrate GPU workloads, because that's where the next big bottleneck is going to be. The hooks aren't there in the NVIDIA toolsets yet for the CUDA toolsets in a lot of places to be able to get what we need for data. We're figuring our way around that. They tend to be much larger, so the time taken to move them very expensive. It might be 20 minutes to be able to move a job from one to the other because it took 20 minutes to get it started up in the first place, just due to the size of the models and how much data you have to replicate. We're starting to put some POC work into the GPU side of things while we're continuing on full steam with building out the expansion and feature set of the CPU and memory-based workloads.
All right, Dan, I was curious if you've seen on the implementation side of this, when we talk about the need to live migrate a pod, whether it's for maintenance, and I almost feel like the next level is the idea of spot instances. I love that idea of my infrastructure dynamically failing and my applications can handle it. Is there a maturity level where you see people start out? It's hard for me to imagine, like on day one, someone's like, yeah, let's just put it all on spot instances and YOLO. Let's just, we don't care. It's all good. Live migration will solve it all. Because obviously there are physics limits to the amount of data we can transmit over the wire. I'm imagining this scenario where you're accrediting certain workloads, like this replica set is good for spot because it's low data. We don't need to transfer 100 gig of data during a 2-minute outage or a 2-minute notice of outage. Do you see that as a maturity scale where you have to implement?
Yeah, I mean, it's absolutely a maturity scale, right? Kind of going back to the references we talked early days of VMware. Nobody started doing vMotion in production. Everyone started it. Oh, we've got this 5-second interruption. Development and test boxes can handle that all day long. So it's the same concept really that we're living in now. We're going through that same evolution. I agree with Phil. I think we're doing it much faster than VMware did in 2002, 2003.
Yeah.
I was around when that happened as well. So I remember racking and stacking all those boxes. But yeah, it's very much the same thing. Container live migration is brand new. We've just been GA for a month with it. So we've had conversations at trade shows and with customers, and there's a lot of excitement around it. I think we're still trying to figure out where it fits, what are the exact workloads that make the most sense to do this in. And yeah, I think it's going to be a process of adoption. There's definitely a lot of use cases. I think the spot is a very interesting use case, especially the large data models, things we're processing today. I'm working with a customer now that's doing a lot of video processing in Kubernetes. And that's a very, CPU and memory intensive job. I mean, we're talking a cluster that scales from 80 CPUs to 6,500 CPUs while they're processing this. We're really trying to figure out where it makes the most sense to apply this type of technology.
No one wants to have that kind of dynamic scale and then have to pay for reserved instances for all of that, like worst case scenario. That sounds like a billing nightmare.
Well, and you don't want a job that runs for, hours that costs you tons of money to fail 80% through and have to restart it. I mean, that's just not efficient. So yeah, I think the ability to really move this and allow those workloads to finish is going to be huge for the market.
All right, so I've been talking a lot about the problem and some of the solution. We do have some slides that give visualizations for those on YouTube. This will turn into a podcast, so audio listeners, we will give you the alt text version of it while we're talking about it. But Philip, I'm just going to throw up your slides on screen because it helps with the understanding of what is happening and the process of how a live migration, like how does it kick off? what's really going on in the background when it starts?
Absolutely. And we do have some better demos other places, I think, on the website. Unfortunately, I didn't have the best one pulled up right now, but I can talk through what we have here. Basically, what we have is a live migration controller looking across all the workloads and nodes that are live migration enabled. You don't necessarily have to turn this on for everything. You've got all your stateless workloads. You don't need to live migration stateless workloads. Just treat them as normal. You've got your stateful workloads that you do want this to use for. So you could set up a specific, node group for that. That's going to allow you to select what you actually want to do live migration for. You could use it for everything, but it just eats up more network bandwidth if you're using it for the stuff that already tolerates being moved. That controller is going to be looking for different signals within the cluster of when something needs to be live migrated. Distance interruption is a good one. Being able to do bin packing, evicting a node from the cluster because it's underutilized, and then migrating those workloads to another node in the cluster. What we call rebalancing, basically rebuilding the cluster with a new set of nodes. And that could be because you're doing a node upgrade, you're doing a Kubernetes upgrade, you're doing an OS upgrade. You're just trying to get a more efficient set of nodes. All of those are good reasons that you would want to do your live migration. So what's going to happen in that process is the two daemon sets on the source node and the destination node are going to start talking to each other. They're going to look at the pods on the source node, start synchronizing them over to the destination node. So behind the scenes, all of that kind of memory is being copied over, any disk states being copied over, any TCP/IP connection statuses are being copied over, and you're doing all that prep work behind the scenes. If you have ephemeral storage on the node, that'll start getting copied. Obviously, depending on how much, it's going to depend on how long it takes. Once the two nodes have identical copies of the data, that's when the lag controller will say, it's time to cut over. It will cut the connections from one, pause it, and put it into a paused state in container D. Then it will unpause on the new node. It'll come up with a new name. Right now we call it clone 1, clone 2. We just add clone to them so you can tell which was the before and which was the after. When that clone 1 unpauses, then traffic will be going to it. It'll have the same exact IP address that it had while it was on the previous node. All the traffic continues on to that node. It picks up exactly where it left off, and the old pod disappears, right? The old pod gets shut down and torn down. If you have something like a PVC attached, so if you've got an EBS PVC attached, there is a longer pause because you have to do a detach reattach with the API calls. It works. It just takes a little bit longer for that pause state. That's the downfall of having to work with APIs. It takes time to do an unbind rebind to the new node. But it works today. If you're using NFS where you can do a multi-attach, then it's instant. It doesn't actually add any delay. It just NFS is a slower storage technology. So does that sort of make sense from a high level?
Yeah. When we talk about Cast AI as a solution to do live migrations based on certain criteria, is it making decisions around, if you say I want a bin pack all the time, in the background, is it just like doing live migrations on your behalf? Or is this something where you're largely doing it with humans clicking buttons and controlling the chaos?
No, this goes back to what we had talked about at the beginning, where automation is key. When a node is underutilized, our bin packer is probably the most sophisticated on the market. It analyzes and runs live tests on every node in the cluster of whether that node can be deleted, whether that node doesn't need to be there anymore. And it'll simulate all the pods being redistributed throughout the cluster. If the answer is we don't need this node, it would automatically kick off a live migration of all the pods on that node. Once it's empty, it'll just get garbage collected. Once it's gone, all your pods are running on the new nodes. Everything's moved seamlessly. You haven't seen any eruption. And the cluster keeps continuing as normal. Most of our customers do scheduled rebalances. So those are just in the background. It's evaluating how efficiently designed the nodes in the cluster are. If the nodes in the cluster are not as efficient as they could be, and different shapes and sizes would be better for that setup at that point in the day based on the mixture of workloads there, it'll do a blue-green deployment, set up new nodes, live migrate the workloads to those new nodes, and tear down the old ones. So everything that we're talking about here can either be scheduled or it's automatic. It's running every few minutes on a cycle. But yeah, no, it's entirely seamless to the users.
Nice. So in the technical details, we're moving the IP address. I think you had a diagram showing the pod on the nodes. When we get down to the nitty gritty of Kubernetes level stuff, pod is recreated, but pod names have to be unique. You can't have the IP on both nodes at once. And then there's the difference between TCP and UDP and other, IP protocols. And there's a lot of little devils in the details that I'm super interested in. We won't have time to go into all of it. But I do remember you showed the pod that you're creating. Step one is we create a pod and download an image, right? This is all still going through container D. So there's not like voodoo magic in the background happening outside of the purview of container D. Maybe you can talk about that for a minute.
Right, exactly. So by changing the pod name, you now have a placeholder for your new pod information to go into. And it does maintain the same IP address when it moves over from one to the other. So to your point, that's when that switch has to kick in, where the old pod definition disappears and the new pod definition appears in your control plane with the API calls up to your Kube API. That cutover is extremely important because you can't have the same pod living in the same place twice. That's why we do have to change his name when we switch it over. There's certain services that cause some tricks because they have an operator structure where they expect there to be a certain pod name. So when you move it, you add the clone suffix to it. We're working on finding workarounds to that in certain areas. So that is a little bit tricky on certain workloads because you can't have the same pod existing with the same name in two different spots. They have to be unique. But yeah, definitely.
The IP is the same, but the pod name is going to have a clone-1 or something like that on it.
Yep.
Yeah, so it starts with your pod, and then there's an event that happens outside of the pod that is talking to container D, and your second pod.
Correct. It's a placeholder, and because the placeholder pod is actually still in a paused state, it can have the same IP address. It's not actually routing traffic to it because it's not an active pod yet. It'll be in a staged state. So you stage it up with all the information, but it has to be named differently. And then when you do the cutover, that's when you switch it from being inactive to active and switch the old pod to be inactive. And that's the final stage when the clone pod becomes the primary. And because it's maintained the exact IP address within the system, it's not losing any traffic. So the networking system within Kubernetes routes it to the new node, and the routing tables are updated, and the pod goes to the new destination.
Yeah, that does sound like the hard part of like the old pod is shut down so the IP can be released. I assume the IP can't be taken out while that old pod is still active. It's one of these things where it's like, I understand it at the theory level, but I have no idea what container D and kube proxy and all these different things that are binding to a virtual interface and the order of the things that have to happen in the exact right sequence in order for you to first assign that IP to the new node and then also replay all the packets. It does seem like a very discrete order of things that have to happen. It has to go in a certain order or it'll just all fail, it feels like.
So that's the part that took us about a year to figure out. There have been a lot of studies and some research papers around the moving of memory and the snapshotting of different workloads. Like that part was a little bit more straightforward because it was really out of the vMotion playbook days from early on. There were also some college studies around using cryo to replicate and migrate containers. None of them had been able to solve the IP side of things, the connectivity side of things. That's what CastAI was able to solve for. And it took a lot of research, took a lot of in-depth work. We started on this early 2024 with a team of about 5 engineers, deep kernel level Linux engineers, Kubernetes engineers, people very familiar with the code. They contributed to the Kubernetes open source project. It was 10 months before we had a demo, and that was using Calico. Before we could demo, we had to have a custom AMI at that point in time in AWS because everything was kernel level at the AMI level. We knew that was not feasible going forward to production, but that was the first demoable version. Like anything else, there's a lot of warts and vaporware in the first version. Since then, we were able to move the logic up to a container D plugin, makes it a lot more portable. Now it can be applied to different clouds. It's much less invasive. You don't need a specific AMI under the hood anymore. We were able to move it to the AWS VPC CNI, so you don't need the custom Calico CNI. All of those were iterative steps to build this and make it more production viable and adoptable by the industry. Now it's a matter of, we've got kind of 2 forks going on. One is continuing to build out additional platforms, figuring out Cilium, figuring out Azure CNI. The other is performance tuning the existing migrations, reducing time to migrate, being able to reduce the size of the deltas down further and further so we can migrate it faster and faster. So we've got kind of those 2 tracks right now. The team's up to, I think, 10 or 12 engineers kind of working on those 2 paths. And this is probably one of our most heavily invested areas in the company is being able to further this technology because we see how much value it brings.
Yeah. And imagine it won't be very long where, this technology is pretty advanced, but like others eventually will probably, if it's truly the thing that we all are looking for, and it sounds like it feels like it is, it feels like the kind of tooling where it's a hard problem to solve and we'll maybe see other people attempt to do it. I mean, the research I had to do for the show, because I was very curious, I was like, what's the history of all this? And someone mentioned CRIU, which I believe you're using at least some of that. That's a project that's been around for quite some time, over a decade, and it's not a new idea. But like a lot of these other technologies, the devil's in the details. We never really had an ability to capture and understand what a binary's true dependencies were, whether it's disk or networking things, until we had containers. You mentioned on here, like it's in LXC, it's in Docker, it's in Podman. Like this actually tool is used widely. It's just maybe not well known to us end users because it's packaged as a part of other tooling. And I can sort of see a world where if this becomes more widespread, you're going to end up with haves and have-nots, where my solution doesn't have live migration or my solution does have live migration. At some point, maybe it's ubiquitous. You're building functionality on top of it, like your automation that truly adds value around spot instances where my company maybe has never done spot instances because it was too risky for us and we didn't have the tooling to take advantage of it without risking downtime. I definitely have a couple of clients that I've worked with over the last couple of years that are like that, where they're 100% reserved instances because they want the cheapest, but they also need to guarantee uptime, and they can't do that at a level that live migrations would provide. So they have to pay that extra surcharge for avoiding ephemeral instances and stuff like that. To me, it gives me comfort that the technology stack is part open source, part community driven. There's also the product and private IP side of this as well, but it's not like you're reinventing the Linux kernel. It wouldn't have been that long ago where you had to actually throw in Linux module or kernel module rather that would only work on certain operating system distributions of Linux, and that you would have to deploy a custom ISO. That wasn't that far in the past, but now that we've got all these modern things, I don't know if eBPF is involved in this at all, but we've got more modern abstractions that it feels like you can just plug and play as long as you've got the right networking components. From an engineering perspective, pretty awesome because it allows you to build stuff on the stack like this. The team's not on the call, but the team that's developing this, good job, bravo. That's some great engineering. Obviously, anytime something is a year-long effort to crack a nut like this, I feel sad for the people that had a 6-month, like no one's going to see this feature for a year and I'm going to work all year on it and I hope someone likes it. So that's, from a software development perspective, that's the hard part. That's the true engineering.
Yeah, absolutely.
We could talk about this forever, but people have their jobs to do. Okay, how do people get started? Do they just go sign up for Cast AI and this is like a feature out of the box that they can implement in their clusters, or?
Yep, absolutely. It's in the UI now, so if people want to sign up and onboard, we do recommend having somebody on our sales engineering team work with folks, so reach out to us. We'll also reach out when people sign up as well. It's all straightforward. There's no caveats. It's Helm charts to do the install, and then you set up the autoscaler. We will be adding support for Carpenter. Today it's using our autoscaler, but we will support Carpenter around end of Q4 or early Q1 autoscaler.
Yeah, that's great. My usual co-host is with AWS, so they would greatly appreciate that. I know that over the last year, Carpenter's been out all over a year. We've had a surprising number of people on our Discord server. For those of you watching, there's a Discord server you can join. There's a lot of people on Discord talking about using Carpenter. I'm really impressed with the uptake on that project. And in case you're wondering what the Carpenter is, it's with a K, and it's for Kubernetes. You can look on this YouTube channel later because we did a show on it and had people talking about it on the show and demoing it whenever it was released. I think that was 2024. I can't remember exactly. All right, so everyone knows how to get started. Everyone now knows that they wish they had live migrations and they currently don't unless they're a Cast AI customer. Where can we find you on the internet? Where can people learn more about what you're doing? Are you going to be at conferences soon? I'm assuming Cast AI is probably going to have a booth at KubeCon again. They always seem to have a booth there.
We've got a big booth at KubeCon this year. I think we've got a 20 by 20. We're going to be doing demos and presentations in the booth. This is going to be a big part of that. We'll also be at reInvent in Vegas in early December, I guess is first week of December. So I'll be at both of those events. I'm also really active on LinkedIn. So if anybody wants to reach out to me on LinkedIn, if you want to set up a session just to go into more detail, feel free to ping me. I post a lot of Kubernetes content in general, best practices, things that we see in the industry from Kubernetes evolution side of things, and also obviously a bunch of cast stuff. So, feel free to follow, connect. I'm happy to share more information.
Awesome. Well, I'm looking forward to hearing about that continual proliferation of all things live migration on every possible setup. Someday it'll be on FreeBSD with some esoteric Kubernetes variant. It's pretty cool to see the evolution of this. Well, thank you both for being here, Philip and Dan. See you all later. Ciao. Thanks for watching, and I'll see you in the next episode.